Harry, thank you very much for the opportunity to do this. Talking about research publication and how to get your research published is something that I enjoy doing very much. And although it was quite a while ago, I still do remember what it was like to write my first manuscript. It was fun, it was exciting, and it was a little bit intimidating, but it worked out okay. And you know, we're all in the business of education, and writing manuscripts and getting them published is really all about education. So I want to, in the next 15 minutes or so, give you a very high-level view and some personal perspectives on scientific publication. And when I think about manuscript preparation, I think about three essential components. There is the scientific part of a manuscript, as sometimes we call scientific rigor. There is the actual writing and the presentation in the manuscript, and that involves transparency and clarity of presentation. And then there's the integrity piece. And that's something that most people don't think about or talk about, but it is an essential part of scholarly publication. And when people run into problems, more often than not, it's in the integrity area, not in the science area or the writing area, if you will. Some perspectives. A well-written article is no guarantee that the science is credible and people will accept the message, but a poorly written article is much more likely to result in an article that's not well communicated and not well accepted and not thought to be credible. Publication is not a guarantee of quality in some ways, because we know with the proliferation of manuscripts and journals rather, that publication is sometimes a metric of persistence, but nonetheless we want to strive for publication in the highest quality journals that we can. And so my goal is to help you understand what it takes to put together manuscripts that are of high quality and likely to get published in a high quality journal. To talk about the process of getting a manuscript published, there's the manuscript preparation, and assuming, of course, that you've done the science, there's the submission of the manuscript. It then undergoes review, and it may undergo revision. It may get rejected, and you then have to regroup and rethink. Hopefully, it gets accepted, but throughout the entire process, I want you to keep in mind that the parts of your manuscript that are most commonly read by most readers is the title and the abstract. You're going to put a tremendous amount of time and effort into the entire manuscript, but most people are going to read the title and the abstract. So you really want to make sure that those are very, very clear and well written. When it comes to the writing, I like to talk about certain stools, or three-legged stools, if you will. There's the science, there's the writing, and there's the ethics, as I've described. And I call these three-legged stools because with these components, if you don't have one of those legs, your entire stool falls over. There's the issue of clarity, clarity of purpose, clarity of the communication, and clarity of the presentation. You want to identify your target mission. What's the purpose of your manuscript? You want to identify your target audience, and you want to identify your target journal before you start doing the writing. Now, sometimes you may sit down and write a manuscript, which is sort of a master manuscript, and then you may tailor it for a specific audience or a specific journal. That's a matter of personal style. Always read the instructions to authors of the journal to which you are going to submit, and after you've done reading carefully the instructions to authors, read them again and again. I suggest that you print out a copy of those instructions to authors and have them on your desktop throughout the entire time that you're writing the manuscript, so you can check them and refer to them and really use them as a guide for that specific journal to which you are going to submit. Very often we get manuscripts in anesthesiology that have very clearly been written for another journal. And that's generally something which gets noticed, and it doesn't endear the manuscript to the reviewers. If you've never published or in that journal, you've never read articles in that journal, go read a few in that journal so you get a really good idea of what the look and feel and style of articles in that journal. And then lastly, get your head in the zone. Write your article with the reader in mind. Put yourselves in the shoes of the person reading the article. What do they need to know, and how can you best communicate what you want them to know? So you're going to sit down and you're going to write an article, and there's a blank sheet of paper. And your mind may go blank as well. And that's sort of the fear. Where do I start? How do I do this? You may feel like you're standing at the bottom of a cliff, and you've got to climb up that cliff. And how are you going to do that? Well, the goal is to get to the top of that cliff. And it's a little bit of a straight up journey. But it's kind of like eating an elephant. You know, how do you eat an elephant? And the answer is one bite at a time. Chunk it up. And understand that the process of writing a manuscript is a little bit different than the process of reading an article. Most people that read an article start with the title and look at the authors and maybe read the summary and a table of contents and read the abstract. You're going to look at the introduction and then the hypothesis and the methods, the results, and then the discussion. It's pretty much a linear process. And we think about the core of a manuscript. It's the introduction, the methods, the results, and the conclusions. Why was this done? How was this done? What did you find? And what does it mean? That's the essence. But you don't necessarily want to write, or you certainly don't have to write a manuscript in that order. Assuming you've decided who the authors are, identified who the corresponding author will be, you've done the experiments, you've done the data analysis, and you've decided who the audience in the journal is going to be, put together your data, the figures and the tables, because that's all factual material. I find that it's easier to write in the path of starting with what's factual and then moving more towards what's creative, as opposed to starting with what's creative, because that's standing at the bottom of the cliff. So work on figures and tables and legends to those figures. Write out the methods and the material, the experimental protocols. Again, this is the what. The what is very factual. Then write the results section. That too is very factual. And then move to the more creative sections, the discussion sections, the conclusion, and the introduction. And then work on the title and the abstract, the two most important parts of the manuscript. Because now that you've worked your way through the entire manuscript, you have a really good sense of the guts and what it means. And that's the title and the abstract. And then you'll work on some of the more administrative parts. Work from the easier to the harder. You've got to decide what kind of a manuscript you're going to write. Is it original research? Is it prospective? Is it retrospective? Is it a review article? Is it a case report? Is it a guideline document, a consensus statement? There are vast and varied kinds of manuscript types. So make sure you have a really good understanding of what type of manuscript it is that you want to write. And then there are guidelines for reporting many of these kinds of manuscripts. There's a website for what's called the Equator Network. And the Equator Network generates guidelines on how to write different kinds of manuscripts. And many of those guidelines also have checklists. Varying journals will have varying requirements as to how and whether you need to really follow those guidelines. But those guidelines are a good thing to read. And some journals do require that you have to submit a checklist along with the manuscript to make sure that you've included all of the important parts of that manuscript. As of a couple of months ago, there were 429 manuscript reporting guidelines on the Equator website. That's a good place to start. I'll come back to the title. The abstract may be the only portion of an article that's read, and it has to stand alone. It should really carefully communicate the purpose, the why, the key methods. And by key methods, we mean that Somebody reading the results in your abstract should be able to understand the methods that were used to generate those results. You want to describe the results using actual data, numbers, statistics, and variances such as standard deviations. And then state the conclusions. Make sure those conclusions are based on the results that you've presented. And don't just restate the results as the conclusion. Tell your reader what the results mean and what they should do with the information. The introduction is the why. What's the scientific premise? What's the problem that you studied? A little bit of background, of context. What was the purpose of your investigation and what was the hypothesis? Remember, we all started in grade school learning about a hypothesis, and that is the essence of the scientific method. Now, not everything needs a hypothesis, but everything needs a research question. And be aware of something that we call harking, which stands for hypothesis after the results are known. Good reviewers can tell if somebody created a hypothesis after they did the experiment. And generally, a good introduction will end with an aim and that hypothesis. There's different kinds of research questions: qualitative questions, quantitative questions, experiential. We talk about nausea and vomiting after anesthesia. You could be have a qualitative study. What was the experience like? It could be quantitative. How often did people vomit after anesthesia? It could be observational. What were the characteristics associated? Or it could be interventional. What was the effect of drug A versus drug B on the incidence of nausea and vomiting? And there's a little bit of a paradigm that some people use called PICO. Describe the population, the intervention, the comparators, the outcome, and the time frame. The methods section is factual. You're just going to describe what you did. Make sure that you have the ethics in there, whether it was a human study and an IRB or an animal study and an animal studies committee. Make sure you list the clinical trials registration, and then list all of the methods that were used to generate the data. I'm not going to go through all of these individually because these simply are representations or examples of factual things that you can do. Make sure that if it's observational research, that there was an a priori, meaning ahead of time, data analysis plan. The research design should come before accessing the results, and certainly before coming up with the plan for research, and then make sure that you've described the statistical methods very carefully. The results, again, are very factual. Describe the population, if it's a human study, the numbers of individuals, the randomization, make sure that the numbers add up, and then present the data. You're going to present data in text or figures or tables, and different kinds of data lend themselves to presentation by one or of those methods, but generally don't present using more than one method. Don't put data in figures and tables. Don't put data in tables and then repeat them in the text of the article. And make sure that those figures and tables are very clearly presented. Putting together figures is an art. And I'll recommend to you a very, very good book on the visual display of quantitative information. It's by Edward Tufte. It's a classic. It's a few decades old, but it is outstanding. It tells you how to clearly and concisely present data in the form of figures. Make sure that the figures that you present are then closely integrated with the text that you put in your results section, and make sure that you've maximized the amount of information in each figure without it being overly crowded. You're going to describe the statistical significance of data. There's a lot of controversy these days about p-values and the over-interpretation of p-values. And I'll simply say that if you're not schooled in statistics, speak with a statistician. Get help on this. Make sure that you're using the correct methods of statistical analysis for the data that you have. Make sure that you appropriately interpret what a p-value means. And understand that there's a tendency to overinterpret p-values. Dichotomization is a result of p-values at the 0.05 level of significance can be a challenge. A p-value of 0.049 compared to a p-value of 0.051 means a difference between, quote, a positive and a negative outcome, but obviously we all know that science is more subtle than that. And be careful of p-hacking. P-hacking means that you're going to take your data, you're going to run it through a statistical analysis and hope that a magical p-value less than 0.05 drops out. And that's not a good way to do science. You're going to write the discussion. Basically, what do the data mean? What's the message? What's the take-home message for your reader? As you write the discussion section, you want to state the hypothesis and very briefly summarize the findings. And do those findings address the hypothesis? Do they substantiate or do they refute the hypothesis? Start your discussion with the primary outcome measure. A good study will have one primary outcome measure and then multiple secondary outcome measures. Always present in the results section the primary outcome first, and always discuss in the discussion section the primary outcome first. And what's the conclusion from the data? Then talk about the interpretation of the data. Any mechanistic insights. How can you explain to the reader how the results were obtained and what do they mean? Then go on to talk about how they fit with pre-existing knowledge. What are the strengths of the study and what are the potential weaknesses of the study? Are there any new questions that arise as a result of the data? Understand that more research is needed is not a conclusion. We can always do more research. But your conclusions should tie back to your research question, your research aims, and your research hypothesis. And then lastly, make sure that you've avoided the tendency to be speculative, overinterpret, or spin the results in your study. And spin means that you've really overinterpreted or oversold or tried to provide interpretations that are really not supported by the data. Beware of a lot of problems with discussion sections, and I won't go through these. I'll let you read them on your own, but again, avoid the tendency towards spin, which is providing interpretations that are not supported by the data. It's overselling. Stay within yourself. Stay within your data. The art and the science of the title. The title is the most commonly read part of an article. It's going to determine whether your article is found when people are doing PubMed and Google searches. It's going to determine whether somebody reads your article. Understand that shorter titles are generally better. Make sure that you've got good keywords in your title and that words which don't convey meaning are not part of the title. Things like effect of, or comparison of, or clinical study of really don't convey any meaning. The first 65 characters in your title are the most important. So make it clear, make it concise, but make it very communicative. So you've written your manuscript and now you're going to submit it. It's not quite straightforward. Again, read the instructions to authors. Make sure that the manuscript style conforms to the style of the journal. Again, read the instructions to authors. Now, some of this may seem very technical or very picky, but it's their journal and it's their rules. So your best shot is your first shot. So make sure that you comply with the instructions to authors. The corresponding author of the manuscript will do all the communication. That person will be the individual who communicates and sends the manuscript to the journal, communicates back to all the other authors, and is responsible for ultimately submitting the manuscript or any revisions. There's different kinds of journals. There's open access journals. There's controlled circulation journals. There's peer-reviewed journals, and there's not peer-reviewed journals. But beware of predatory journals. And those are journals that will offer to publish your article in return for a very substantial fee, and very often those are not peer-reviewed or high-quality journals. So your manuscript's going to get reviewed. And these are the basic aspects of peer review. A journal is going to send your manuscript out to a couple of reviewers, and they're going to want to know the answer to a few things. Is it an important research question? Is there a hypothesis? Do the experiments adequately test the hypothesis? Are they appropriate? Are they appropriately presented? Are the results valid? And are the conclusions supported by the data? So the reviewers are really there to help you as an author, but understand that they're asked to prepare a critique, and it's called a critique for a reason. So you'll get that critique back, carefully review the message in that critique. There's different kinds of peer review, single blind and double blind. The most common form is single blind. And I'll let you look at this slide offline later. So just to kind of wrap up, and I'll take this as far as the outcome of the submission of your manuscript. One of the few things is going to happen. They may reject your manuscript outright. You hope that this doesn't happen. Sometimes it's just not appropriate for the journal. Sometimes it's not of good enough quality to even send out to reviewers. If it gets sent out for a review, the result can be that it could be rejected, or hopefully it could be accepted. And the most common outcome is a revision invitation. And that revision invitation may be specified as, we invite you to submit a revised manuscript, or it could be as non-committal sounding as, your manuscript is not acceptable in its present form. However, if you wish to undertake a substantial revision, we may be willing to consider a revised manuscript. Hopefully the goal, whether it's with an original submission or a revised submission, is to get to accept. But regardless of the outcome, understand that the peer review process brings substantial benefit to you as an author. The peer review process will help you improve your science, the quality of the methods, the data analysis, the data presentation, the interpretation, the conclusions, and sometimes the need for additional experiments to better substantiate your conclusion. Peer review will also improve the presentation, the clarity of the presentation, sometimes suggestions for improving the figures and tables, making sure that your conclusions are supported by the data, that there's no spin, and that the writing is as clear as possible. So let me stop there, and we'll come back and we'll answer questions for you in the next section.